All right, on to question number 3. As always happens, or I shouldn't say always, almost always happens in these physics situations, problems are going to get a little harder as we keep going. So just a heads up, but we're here, we're going to help you. It's going to be great. All right. So question 3 says a train has an initial velocity of 3 meters per second and then it's going to speed up to 7 meters per second in 9 seconds. What is the train's acceleration? Okay. So the first two questions, velocities were constant. Now we're starting to accelerate. Oh my gosh, you guys, it's going to be great. Okay, so here it goes. Initial velocity, 3 meters per second. Final velocity, 7 meters per second. And the time is 9 seconds. So how do we do this? Well, I don't know. Let's see if we can graph something to figure it out. In this problem, there aren't any positions or any displacements. So doing a position versus time graph doesn't make a lot of sense. Let's go ahead and jump in and start with a velocity versus time graph. Okay, so we're not starting from zero. Did you notice that? We're not starting from zero in this case. We're starting at a velocity of 3 meters per second at a time of zero. So we're going to go from 3 all the way up to 7 in 9 seconds. Now, if you remember from question 1, I think it was, there was a 7 second or 7 meters or something like that. But we realized that we can go by 2. So we're going to go ahead and do that again here. So I'm going to do, this is 1, 2, 3, 4. Put my velocity a little too close there to the axis. Sorry about that. 5, 6, and 7. And this is measured in meters per second. And our time is 9 seconds. So we don't have enough room to double that up. So we'll go ahead and just do it by 1. So this is going to be 2 seconds, 4, 6, 8. This one right here will be 9. And then I'm going to go ahead and put in my 10 measured in seconds. Okay. So let's just see what this looks like. Let's just take a look and see what we can figure out. So we know that the velocity is 3 meters per second when the time is 0, if we're going from 0 seconds to 9 seconds. So we're going to start at 3 right here. And then at 9 seconds, it speeds all the way up to 7 meters per second. So those are the 2 points we know. We're assuming that it's accelerating constantly, and they want to know the acceleration. So remembering from our definitions and remembering from what we know that acceleration means a change in velocity, we want to figure out where we might be able to find that on the graph. So let's take a look. I'm going to take my straight edge again. So get that straight edge or that ruler out, whatever you have that helps you to do that. Try not to make too many funky things happen on my computer while I'm doing this. All right, and then I'm going to go ahead and draw that line. You go ahead and draw your line as well. Like that. All right. So now we need to find the acceleration. Remembering acceleration is change in velocity, not just change in velocity, it's change in velocity over time. Come on, Carboline. All right. And the units of that are meters per second squared. But that's really just meters per second per second. We have meters per second over here and seconds over here. If you didn't know it before, check it out, you guys. Acceleration is really just looking at the slope of the velocity versus time graph. That's pretty cool. That is worthy of some pretty sparkly pen acknowledgement. All right, so we just need to find the slope. We got this. No big deal. Change in y, change in velocity, which in this case is 7 minus 3, which is what, 4 meters per second, divided by the time that it takes, which was, what was that, 9 seconds. So you got 4 meters per second divided by 9 seconds, and I believe that that's going to give you something like 0.44 meters per second squared, or meters per second. There you go.